Hi there, I'm Francis and I'm going to report Chapter 3 Models and Architecture. Objective: learn the basic design of a graphic system. Introduce pipeline architecture. Examine software components for an interactive graphic system. Image formation revisited. Can we mimic the synthetic camera model to design graphic hardware software? Application Programmer Interface or API. Need only specify objects, materials, viewer, like. But how is the API implemented? Physical approaches. Ray tracing. Follow rays of light from central projection until they either are observed by objects or go off to infinity. Can handle global effects, multiple reflections, translucent objects, slow, must have whole database available at all times. Religiosity. Energy-based approach, very slow. Practical approach. Process objects one at a time in the order they are generated by the application. Can consider only local lighting. Pipeline architecture, vertices, vertex processor, flipper, and primitive assembler, rasterizer, fragment processor, pixels. Application program. All that can be implemented in hardware or on the graphics card. Vertex processing. Much of the work in the pipeline is in converting object representation from one coordinate system to another. Object coordinates, camera, coordinates, screen coordinates, everything of coordinates is equivalent to a matrix transformation. Vertex processor also computes vertex colors. Projection. Projection is the process that combines the 3D viewer with the 3D objects to produce the 2D image. Perspective projection. All projectors meet at the center of projection. Parallel projection. Projectors are parallel. Central projection is replaced by the direction of projection. Primitive assembly. Vertices must be collected into geometric objects before flipping and rasterization can take place. Line segments, polygons, curves and surfaces. Flipping. The real camera cannot see the whole world. The virtual camera can only see part of the world or object space. Objects that are not within this volume are said to be clipped out of the scene. Rasterization. If an object is not clipped out, the appropriate pixels in the frame buffer must be assigned colors. Rasterizer produces a set of fragments for each object. Fragments are potential pixels, have a location in frame buffer, color and depth attributes. Vertex attributes are interpolated over objects by the rasterizer. Fragment processing. Fragments are processed to determine the color of the corresponding pixel in the frame buffer. Colors can be determined by texture mapping or interpolation of vertex colors. Fragments may be blocked by other fragments closer to the camera. The programmer's interface. Programmers the graphic system plays of entities. The application programmer interface. Application program, graphics library or hardware, keyboard, mouse, CRT. API content. Function that specify what you need to form an image. Object, viewer, light sources, materials, other information. Input from devices such as mouse and keyboard. Capabilities of system. Object specification. Most API support a limited set of primitives including points, 2D objects, line segments, 1D objects, polygons, 2D objects, some curves and surfaces, quadratic, parametric polynomials. All are defined through location space of vertices. Sample. GL begin GL polygon. GL vertex 3F 0.0, 0.0, 0.0. GL vertex 3F 0.0, 1.0, 0.0. GL vertex 3F 0.0, 0.0, 1.0. GLN. Camera specification, 6 degrees of freedom, position of center of lens, orientation, lens, film size, orientation of film plane. Lights and materials, types of light, point sources versus distributed sources, spotlights, near and far sources, color properties, material properties, absorption, color properties, scattering, diffuse, specular.